That's really creepy. Love you through when you're sleeping. Okay, Santa, you kind of sound like a stalker. And that's a threat. I mean, what's wrong with a good cry sometimes? Sometimes you're just in a puppy mood. Okay. But is he really? Hello and welcome to another Christmassy Math Monday. Today I want to talk about if Santa Claus is really coming to town and what would be involved if he did. So in today's Math Monday, let's figure out how fast Santa has to go to make it to all the houses that he's going to deliver presents to on Christmas Eve. So how do we figure out speed? Well, here I'm just going to do average speed, which of course is what I tell all my physics students to never do, because most of the time we can calculate all the accelerations and decelerations, but here that would make this calculation just way too difficult and more impossible than it already is. So let's just use the fact that average velocity is equal to distance divided by time. So let's start with distance. We know that there are about 2 billion children in the world, but let's face it, Santa does not visit all of these children. There's plenty that don't celebrate Christmas. So we can actually average that down to a third and say that he visits about 600 million children. Now, when you average 2 children per household, which I think is a good average because some households have a lot more and some households have just 1. That's about 300 million households that Santa is going to visit. So if we're talking about the distance that Santa is going to travel, well, we don't just need to figure out the surface area of the entire world, because he's not going to be going to very unpopulated areas like deserts and vast forests and oceans and things like that. So we need to figure out what's the shortest distance he can go to all 3 billion points that he needs to go to. Now, there is a very famous mathematical problem that is designed to solve a problem just like this. It's called the traveling salesman problem. And that is, if I have, say, 4 points that I want to go to, what is the shortest possible route that visits every single one of those 4 points but ends where it starts? For example, in this diagram that I just drew, if you go from position 1 to 2 to 3 to 4 to 1, then your total distance is 20 plus 35 plus 15 plus 10, which equals 80. So there you go. But if I were to go from 1 to 2 to 4 to 3 to 1, again, I'm going every single point and starting and ending at 1, then that's just 75. So just not going from 2 to 3 directly shaved off 5 meters, kilometers, whatever these units are. I didn't actually label them. So we need to do this, but with 300 million points. Now, computers are actually the only thing that do this problem. We can't really do them once they get longer than, I don't know, 10, because even with just 4 points, you'd have to figure out all the permutations of 1, 2, 3, 4, plus another 1, or plus another 2 or 3 or 4, and then figure out all those distances. Yeah, pass. So with 300 billion points, we'd have to give this to a computer, but even computers can't do this. This is too difficult of a problem to do. So we can't even give this problem to a computer. So we can do a simplified version of the traveling salesman problem for Santa, not with 300 million points, but we can think of very densely populated areas as 1 or 2 points on the map, and that simplified version will get us that Santa needs to travel about 3 million miles. So that's fun. How do you think Santa knows the shortest distance? Do you think he's like actually a better mathematician than all of us and is like trolling us? Or do you think he just like knows from experience, as has done so many different routes and like keeps track of which one is the shortest distance? Anyways, let's talk about the time that it takes Santa. This one's a little bit easier. So our Earth is traveling on its axis counterclockwise, or towards the east, which is kind of weird because then the east is also, yeah, let's just say counterclockwise. So Santa would obviously start at the easternmost point and go clockwise from there, kind of having to dart back up and down somehow. I don't know, but I'm sure we'll figure it out. So Santa has the full 24 hours of Earth's rotation, but say he starts at the beginning of one evening in like Eastern Russia and ends really close to morning in, I don't know, Hawaii? Is that the farthest west? So that gives him almost an extra 8 hours, let's say. So he actually has 32 hours of travel time. In my velocity calculation, I'm actually going to account for the thing that everybody thinks is so ridiculous, is that Santa would just constantly travel for the full 32 hours, not take any bathroom breaks, not take any breaks to stop and deliver presents, not take any breaks to eat all the cookies and give those poor reindeer a rest. So let's say he actually spends a total of half the night, 16 hours, going to the washroom, delivering the presents, eating the cookies, drinking the milk, all that fun stuff, maybe even a power nap or two in there. And let's say for 16 hours is when he is traveling. So if I look at my speed formula, which is equal to distance over time, then that 300 million miles we are going to divide by 16 hours instead of 32. That gets us 187,500 miles per hour. Miles per hour? What physicist measures anything in miles per hour? What's the point of miles? Seriously, imperial system, what is the point of you? Why are there so many random, arbitrary values and the other values? Like, I really don't understand imperial. Okay, the rant is not over. I could rant for so much longer about how ridiculous and messed up imperial is, but I'm gonna try not to. And we're just going to convert this to metric because metric, so much more superior, where all you have to do to convert to one thing to another is move a decimal place. Sorry guys, metric is so much better. So if I want to convert this miles per hour to meters per second, I know that there are 1,609.344 meters in a mile. Look it up. And then I know for every 1 hour, I have 3,600 seconds. So I take 187,500, multiply it by 1,609.344, and divide it by 3,600, and I get 83,820 meters per second. I like this so much better because then we can compare this with other values that we have, like the speed of light, which is 300 million meters per second, or the speed of sound, which is about 343 meters per second. So this is about 250 times the speed of sound. So many people say, well, how's that possible? Because we'd hear the sonic boom as he goes over. NASA has been working on spaceships that don't have sonic boom when they go over the speed of sound. So Santa was able to figure out the traveling salesman problem, so he can probably figure that out. And then there's of course all the problems like how would the reindeer not just burn up? Well, again, Santa, if he's been able to figure out the rest of it, he seems like a pretty good scientist. I think he can figure it out. So if you ask me, we have one of two conclusions. Santa is not real and does not travel at 83,820 meters per second. Or Santa is a really, really good scientist and is not sharing his discoveries with anyone. And really, I don't blame the guy because we just like sit here spending our entire time talking about how he isn't real. So he probably just doesn't want to share his findings with us. So what do you think? Santa, a figment of our imagination or just a really, really good scientist and mathematician? Let me know in the comments. I hope you guys are having a very Merry Christmas time. I'll be coming at you with more Christmas content next week. In the meantime, I hope you have a wonderful Christmassy week and I'll see you next week.